Good morning, everyone.
Good morning.
Good morning, everyone.
Good morning.
Welcome to the 2012-2013 season of Primetime at the BU Library. I'm Keith Brooks, part of the Faculty Development Team in the Education Department. Primetime is a year-long celebration of the academic and experiential accomplishments of our faculty, students, and staff, and is a collaboration between friends of the BU Library and many offices on campus. Join us on Thursday, October 25th, as Taylor Rafferty shares her study of broad experience entitled Ripples and Reflections of Cambodia. Today we welcome Professor of Math and Computer Science, President of the Friends of the BU Library, Dr. Eric Gossett, as he presents Math and Anime, explaining the gap in math performance between American and Asian students. Let's welcome him.
Thank you. This is actually a trimmed down version of a longer talk, and I'll indicate the parts that I'm going to kind of skip over. But here's some of the, I'm going to mostly skip over this idea of math idiots and math geniuses, but I'll talk a little bit about it. Spend some time talking about why Asian students have historically performed better at math than American students, with some research to base that on. Some math content and anime, again, a lot of that's going to be kind of skipped over, but I'll talk a little bit about it. And end up with, and I don't see a whole lot of future elementary teachers here, but why elementary teachers and parents should understand mathematics. I think probably the greatest movie clip on math there is, so we'll end with that and then some comments and questions. So here are some brief facts and statistics. In this talk, the ratio of anime to talk is about 1-to-1, so you don't have to listen to me the whole time. The number of anime shows directly referenced, if I counted right, is 11. The video, I'm going to show only 4 clips in this abbreviated talk, but here's the minimum, maximum, average clip length, just to have some statistics. I got to sneak it in. Okay, and no animals were harmed. That just says, ah. Okay. So the origins of this presentation, I watch a lot of anime, and my perception is that anime and Japanese shows in general are quite willing to present mathematics as a normal part of a typical high school student's education. And American shows seldom mention mathematics. And when they do, it's usually with a negative connotation. So some other person just says, here's people's response to the fact that I'm a math major. You know, wow, you must really be smart. Do you want to teach? Or I hate math. You know, so kind of shut down. So I thought, you know, it would be nice to try and think about why does the Japanese culture have so much more willingness to present math. Math even shows up, I guess I do want to show this. Oops. Even in shows aimed at very young children. This is a clip out of an adaptation of the Hans Christian Andersen Snow Queen fairy tale. In the kid market, you're going to have to learn how to read subtitles, but that's okay. So you're all college people.
麦を刈り取った後、集めきれずに実のついたまま放置された方を落ち穂という。その落ち穂を畑の持ち主から許されて拾うことを落ち穂拾いという。落ち穂もたくさん集めてその実を粉にすればちゃんとしたパンになる。当時落ち穂拾いは貧しい人々にとってはかなりの恵みとなる行事であった。
ありがとうよみね。あらあらら、ちょっとワイダメでしょ、こんなところでサボってちゃ。サボっちゃいないさ、計算してたんだ。計算？何の？落ち葉の計算さ。いいかい？落ち葉1本についている実の数はほぼ20粒。パンを1斤作るのには 280g の粉が必要だから、1本の穂から取れる粉の量を 0.5g とすると1斤分の粉を作るには560本の落ち葉が必要となる。どう？ 560本拾おうと思うだけで疲れない？ダメ。やっぱりサボってる。そうかな。
Okay, well his math was correct, by the way. anime has let's see. We need to do some kind of a resync, right? Well, that's coming out of my Disney card. Hang on a second, we're going to lose weight too much. I didn't notice this earlier. All right, I give up. So, yes.
Resize on the remote because you're out.
Oh, did I? There we go. Okay, so there we go. All right, so that did fix it. Thank you. So there's a number of shows that actually show. You might think when I'm going to talk about why the Asian kids do better at math, that all Asian kids are just great at math, and there's lots of references to students flunking math tests and things in anime and other tests. And so you got some all-purpose idiots. If you've heard of the old show Sailor Moon, the main character, Sailor Moon herself, is a total knucklehead. Story name, I wished I could show you some clips from that, is actually a very bright young woman who's kind of a screwball, but just doesn't do well in math, and there's some great interaction with her and her math teacher that I had to cut out of this. This is quite fun. But they also show some math geniuses, and we'll see a little bit here. Squid Girl is a squid who's come out of the ocean to take over the world because people have polluted the ocean, and she ends up on a beachfront noodle shop with a set of siblings, but she's quite good at math, it turns out. And so she even goes on a little bit later to talk about Fourier analysis and Poisson distributions, and I'll mention her one more time. But let's get on to the one of the two main features here. Why have Asian students done better at math historically than American students? And there's a couple of researchers, education researchers, Harold Stevenson and James Spigler, who wrote a book in 1992 that the learning gap, why our students are failing compared to the Japanese and Chinese. And what they actually did, part of the study is they went to Sendai, Japan, Taipei, Taiwan, and Minneapolis, and did some comparisons and looked at families and talked to the parents and stuff, and some of the things that they came up with are rather interesting. So one of the reasons that they say, okay, here's some of the factors why the Asian students do better, they spend more time in school. And they spend more time in school in several ways. More days in class, longer in class. I'll mention a couple others. This one is just sort of an excuse to get the math idiot view in there. So here's a little scene from a typical school day where some students have just gotten back the math test. Doesn't totally address the more time in school, but gives all this an excuse to show anime anyway.
なんだ、意外と大丈夫じゃないか。おい結構、テストどうだった？かな？うん。65点だ。赤点覚悟だったけど、まあまあだな。そうだね。で、結構は？100点。100点中100点？100発100中ってこと？ノーミスってこと？パーフェクトってこと？ 実につまらん。なんて面白くない点数だ。そんなに計算が得意なら電卓にでもなればいい。この電卓め。そこまで言わなくても。それに比べ65点。なんで人間らしい点数なんだ。電卓に喧嘩を売ってもつまらんな。誰か勝負になりそうなやつを。
おい南、テストどうだった？
来たな番長。また私に勝負を挑む気か。
あ、番長？
さあ何点で勝負するんだ。言ってみろ。ほら軽くひねってやるからサクッと言ってみろ。
あ、いや勝負とかじゃなくて66点だけど。
Okay. So we've got one of the issues then is to spend more time in class, and they do that. But another really biggie is that they have assignments over their breaks. And I'm getting ahead of myself here. Right spot. So they have a couple of big summer break, winter break, and so forth between their semesters, and they have homework to do over the breaks, which is just unheard of. A teacher who would assign homework over summer break in America would get fired. So here's a couple of sisters.
もうすぐゴールデンウィークも終わりだけど、2人とも宿題とかは大丈夫かい？
実はまだだったり。長いお休みってどうしても遊んじゃうんだよね。困っちゃったね。ねえお姉ちゃん。ごめん、私もうほとんど終わってる。ずっと一緒に遊んでたのに。ごちそうさま。ここなんだけどね。鏡がわからないところは私にわかるわけないでしょ。あんた大学生だろ。いい加減司起こしてきて。やだよ、どうせ起きないもん。いい加減に起きなさい。お父さんたち遅いね。午前中は実印祭に行ってるんだ。何時？もうお昼。おかえり。おはよう。もう昼だよ。よくそんなに寝てるね。かなみ、みやきちゃんからお電話よ。はーい。宿題の答え合わせも兼ねて勉強会をやりませんか？おお、いいわね。やろうやろう。かなみ、こなたちゃんからお電話よ。まあ、宿題の掃除を兼ねて勉強会でもってね。ちょっと待て。あんたの場合私の宿題を移すだけでしょうが。というわけで宿題を移させて。めっちゃストレートね。宿題移すのはいいけどね、自分でしっかりやらないと休み明けのテストひどい結果になっちゃうわよ。そうだよね。自分のためにならないもんね。私は一夜漬けが得意だから大丈夫。だから見せて。お前も少しは悩めよ。お邪魔します。あ、いらっしゃい。あら、泉さんの勉強会ですか？いや、こいつは丸打ちし。それにしても全然やってないじゃない。休みの間何してたわけ？数学が23ページ、世界史が20ページ、英語が30ページで、お休みが5日間、1日5時間、いや4時間やるとして、数学1時間 1.15 ページ。今日は全然してないや。残り3日だから1日6時間はするか。あと2日で必死に頑張る。
もうすぐゴールデンウィークも終わりだけど、2人とも宿題とかは大丈夫かい？
まあ、宿題の掃除を兼ねて勉強会でもってね。ちゃんと計画通りにやろうと思ってたんだけど。計画通りだ。無駄な抵抗だったね。お前はなお悪いわ。 自分で頑張ってやってたのか。なんだかんだ言って根が真面目なのよね、この子は。でも世界率は見るに耐えない。ひどいひどい。
Okay. So, most of the students are going to do more than some of these ones. So. Another big issue, which also contributes to the more time on task, is the fact that lots of kids in Taiwan and Japan go to school all day, and then after dinner they go to a private cram school. And this is actually in Korea, a picture from Korea, but it's just huge room with a whole bunch of people and somebody up front lecturing. But it does mean that they spend more time on task. Here's some other family-related reasons. Family support for education is generally much better. Number one, what they found was that in the Asian countries, even though they had smaller houses, the kids all had their own study area. They each had their desk. And so here's a brother and sister. They each have a desk in their room. In America, they found most of the kids were doing the homework on the kitchen table. All kinds of other stuff going around. It's not a permanent place. You don't get into this mindset, this is where I come to study. And they said that was a contributing factor. The expectations are a little different. Whereas in America, the parent may say, you got a C on your math test, we're so happy. In Asia, now Tiger Moms, this book was kind of written tongue-in-cheek and stuff, and people didn't catch that, but there is still a strong sense in the Asian culture, well, of course you're going to do well in school. We just expect it, and here we don't. And that was highlighted a little bit better. What they did with these moms in Sendai, Taipei, and Minneapolis, they said, you got 10 points to allocate among these 4 things: ability, effort, task difficulty, and luck. Which of those contribute to your kid's success in math? And what you notice is that the Asian moms gave a much, relatively speaking, higher weighting than the American moms to effort, and the American moms gave a higher relative rating to ability. In other words, if you're born a math head, you're going to do okay in math class, and otherwise, forget it. It's just a matter of luck. You'll hopefully get an easy test, and yeah, you ought to spend some time working, but they don't have the emphasis that the Asian moms did on work is going to get you through this. Put your time in, do the homework, don't play so much during breaks, and by golly, let me see your test scores. We'll see that a little bit later. We expect you to do well. Okay, on to real quick, some math content on the Squid Girl is an up enough on math, even though she just crawled out of the ocean, to know that there is no Nobel Prize for mathematics, and if you're going to get a prize, it's the Fields Medal. Okay, and somehow she's aware of that. De Morgan's laws, there's a logic version and a set version, but here's the set, that the union of A and B, the complement, what's not in the union is everything that's in both not being in A and not being in B, and then there's a version, so the discrete math graduates all know that one. Even recursion gets shown up, and we'll see that. So here is probably the main event. If you walk away with nothing else, get the moral of this video. This is from a video called Only Yesterday, which is Studio Ghibli. I see they have 3 films from Studio Ghibli here. They're kind of the Japanese equivalent of Disney in terms of status. Spirited Away, Castle in the Sky, Ponyo, Howl's Moving Castle. Only Yesterday also, Disney is distributing. They'll never distribute it in America, and it's a great film. But it's just not going to happen, I don't think. Because it's about this woman who she's a career woman, gone off and is trying to figure out, what do I want to do with my life? Goes out to work on her older sister's in-laws' farm for the summer. And the movie kind of takes place there, and she starts remembering herself as a 5th grader. And unfortunately, in 5th grade, they have sex ed, talk about periods, and I don't think Disney wants to touch that. But this clip is really phenomenal in terms of that. So here's her as an adult. She's talking. 小学校の時に分数の割り算
すぐできた。
あ、
分子と分母ひっくり返してかけるって教わった通りにすんなりできた？
覚えてねえな。まあでも算数そんなに苦手でもなかったけど。
あ、そう。そうよね。覚えてないのにすんなりできたからよ、きっ
と。でもなして急にそんなと。
分数の割り算がすんなりできた人はその後の人生もすんなりいくらしいの。
は？
姉ちゃんっていうね、おっとりした子がいたの。算数全然得意じゃなかったけど素直に分子と分母ひっくり返して100点。その子はずっと素直にすくすく育って今はもうお母さん2人の子持ちよ。私はダメだったのよね。頭悪いくせにこだわるたちなのよね。
テストの前ね、学校だったの。でもってね、吹き絵をやったの。
吹き絵？
そう、画用紙に絵の具を垂らしてね、ふーって吹いて模様を作っていくの。
それで？
ふーって吹くでしょ、ふーって。
だから
頭痛くなっちゃったのよね。ふーってたくさん吹いたから。
それでこの点なの？
そうなの。
そう。間違ったところの正しいお答え分かってるの？
え？
正しいお答えよ。八重子姉ちゃんに教えてもらっときなさいよ。
八重子姉ちゃんに？
そうよ。七子お姉ちゃんでもいいから。
七子姉ちゃんにする。
Check mark means wrong, by the way.
七子姉ちゃんまだ帰ってないから夕ご飯の後でやっていい？八重子姉ちゃんに教えてもらう。何よこれ。どうしてなの？
教えてやってちょうだい。全然分かってないらしいの。
だっていくらなんだってどうしてなの？
だから教えてやってよ。
誰か頭どっかしちゃったんじゃないの？
教えてやってって言ってるでしょ。
だって普通にやってればこんな点取るわけないわよ。
だから普通じゃないの、太鼓。太鼓、八重ちゃんに教えてもらいなさいね。吹き絵で頭が痛かったのよね。ね、太鼓。
座んな。九九を初めから言ってみなさい。
九九なんて言えるわよ。もう5年生だよ。
九九ができるならどうして間違ったのよ。
だって分数の割り算だよ。
分母と分子をひっくり返してかけりゃいいだけじゃないの。学校でそう教わったでしょ。じゃあどうして間違ったの？
八重ちゃん、一つずつ教えてやって。
分数を分数で割るってどういうこと？え？3分の2個のリンゴを4分の1で割るっていうのは、3分の2個のリンゴを4人で分けると1人何個かってことでしょ？うん。だから1、2、3、4、5、6で1人6分の1個。違う。それは掛け算。どうして？かけるのに数が減るの？ 3 分の2個のリンゴを4分の1で割るっていうのは、とにかくリンゴにこだわるから分かんないのよ。掛け算はそのまま、割り算はひっくり返すって覚えればいいの。この人の妹宝塚？妙子算数2なのよ。2？そうよ、ついに2になったのよ。
50点とか60点とかっていうなら叱りようもあるけど。そうよね。妙子、合気調べてもらった方がいいんじゃない？入学の時には普通だって言われたんだけど。
バカになったのかもよ。妙子、赤ん坊の時2階から落っこったでしょ。そう、歩行器に乗ったまんま。あの時は死んじゃったかと思った。
何個も作っただけでしょ。
あれが今頃になって。そうよ、きっとあれよ。
なんか算数が飛び抜けてできないだけだもん。お家のしゃべりばかりしてるのよ。
ちゃんと聞いてれば分数の割り算なんて簡単だもの。バカだってできるわよ。じゃあ3分の2個のリンゴ4分の1で割るなんてどういうことか全然想像できないんだもの。だってそうでしょ。3分の2個のリンゴを4分の1で割るっていうのは、
今考えてみてもやっぱり難しいのよね、分数の割り算。
Okay, so here's a kid, unlike the majority maybe, who just say, teach me the rules and don't make me think, I just want to do this and get the answer. Here is a kid who said, I want to understand, what does this mean? I need to picture it. And evidently the teacher either was too busy to tell her or didn't know she needed that question or didn't know themselves. And certainly the sister knows how to do the rules but doesn't understand the concept, and he says, oh, forget that. You know, just do this. And you're fine. So she wanted to know, what does it mean? Now, she happens to be thinking of, the sister got this part right, she's thinking about multiplying fractions. So the picture that she draws is asking, of 2/3, what's 1/4? And she gets 1/6. The question is asking, what is 2/3 divided by 1/4? And it's asking, how many times can I get something this size to fit into 2/3? And we can get 1/4, we can get another quarter here, and this quarter I'm going to divide into 3 equal parts, and 2 of those go in. And so the answer is 2 2/3 times. And that's the concept that didn't get told to her. Years ago, when I first came to Bethel, there was an English prof who was talking about 3rd grade math and asking a question that ended her math career, basically. She said, why is a minus times a minus a plus? And the answer the teacher gave her was, don't be impertinent. Get back to work. And here was another person who said, I want to understand this, and the teacher was incapable of answering that, so shut her down. And she basically turned off math because of that. So 2 2/3 times. So the standard shortcut is, if I divide this by that, I can do some algebra and do this invert and multiply, and we get that answer. Okay? So I got a little clip that just refers to this movie. This is the scatterbrain girl or the screwball who's talking to her friend and talking, and she quotes this thing about, I knew a girl, and Heiko's talking about her sister, right? I knew a girl who could do this dividing fractions all right every time, and so she's normal and got 2 kids or whatever. But I think I'll just skip over that. So if you were keeping track, there's the anime that actually has been referenced in one manner or another. And I'm open for some questions at this point. We've got a few minutes left. Or I can just show more video clips. I got 5 or 10 minutes I can show some.
Yeah.
Yes.
I had a question, Eric, about helping people to, because I'm one of those math idiots, helping people to understand the concept. So in a sense, what she was doing with the apple was she was using it as a manipulative.
Yes.
So, I mean, do you think the manipulatives in general are a good way, or are those more helpful to people?
They
like
tend to
us?
use those a lot in Asia, and I know now that Scott Brown and Dan Swinson are both here who are experts on this, and we try and train our future LED teachers to be quite comfortable with manipulatives. We've got a course, is that Math for LED 1, isn't it? That does a lot of work with manipulatives so that we can help. And in China and Japan, they do, from what I've heard, and I'm not an expert on this, they tend to do a lot of manipulatives to help the kids to visualize. And, you know, counting on your fingers isn't all bad. So, other questions?
Do you think there's a real dilemma in terms of using manipulatives in the classroom against the limited time that we have and becoming successful at doing that?
Okay, so the trade-off then is if we're using manipulatives, we're not gaining the facts as quickly as if we just rush through and say, here's the procedure, let's do this. Yeah, I think there is something to that if you're going to use the manipulatives, I guess the people that would be promoting the manipulatives would be to say it's better to learn what you're doing well and build on that than to rush through and not have any idea what you're doing. I guess the alternative to that is to say, yeah, we're going to cover all of this stuff and you're just going to spend more time learning it. There's some classes here like that I might teach. Yes?
Do you know if in Asia there's support for the parents in order to support their children? Because I'm with Barrett, I would be one of those math idiots, but I have a 5-year-old, and I'm thinking, I don't know if I'm going to be able to help him with his 3rd grade math homework, but I wouldn't know where to go. Is there that kind of system already in place in several Asian countries?
You know, the Asian schools have their own problems.
Sure.
I mean, bullying is huge, the pressure on kids. My wife went to school, and her junior high school was the top girls' school in the nation, and she remembers one of her classmates, after failing a math exam, cutting off her finger to punish herself. Okay, so the pressure can be enormous, but I think it probably depends on the school as to whether you get the support or not. You know, one of the biggest disasters in America, one of the best ideas in math was the new math, long before most of you sitting here were born. It was a great idea, the right way to teach math, but they implemented it terribly. They didn't train the teachers, and they didn't give any support to the parents on how to do this stuff. During my time here, they started the change in math in the junior high school, which was the, what's the word for the integrated math. And the first couple of years of the integrated math, they had 0, I mean, it was all about discovery learning, and so you didn't even have a textbook to tell you, so mom and dad were out to lunch. And there was no materials to help mom and dad help the kid. Again, it was very poorly, in my opinion, it was very poorly implemented, even though the ideas behind it might have been good. I would just go to the teachers in the school and say, I want some support information. I mean, that's really with the math. I think a lot of subjects we would do better in education if the schools are saying we want parental support, in which case we need to give the parents some help to help their kids. And people who are more active in the ed department, do you guys know, do we have stuff like that going on these days? My kids are all gone from school.
I remember a middle school teacher telling the whole parent group there
don't help your kids with math at home, you won't know how to do it.
Ouch.
Which didn't apply to me, but maybe everybody else.
Okay. And then Scott.
Well, you may have mentioned some responses, but I'm interested in, this study being centered, that you mentioned being centered in Minneapolis, and then comparing it to, has there been much reaction, or maybe you mentioned some resources, but are there places here in Minneapolis that have responded to that study in response to that?
The state of Minnesota, actually about 5 years or so after that came out, I don't remember how long ago, the state of Minnesota actually had an initiative to say we got to get the math and science education in this country up to speed, especially if we're talking about junior high and high school. And they had a conference where they got a whole bunch of people like me, college teachers who were not ed department, content majors, the math teachers, the biology teachers, the chemists, into a conference to say, how do we model for the students in our classes who are the future the future secondary teachers? Because what they found is, what we may say in the ed classes, so Scott and Dan are busy telling them this is the right way to teach, and they come to my class and I do it the wrong way. I'm just standing up there talking and talking and talking in the front. And they go off, and what they do is what they experience, not what they know is right. And so they have this conference to try and get us to change how we're going about things, to model for these future teachers the right way to do things, or the way that's, the right way is maybe too strong, but a more effective way.
Is that the new math you were mentioning? Is that?
No, new math was a way of, instead of learning the rules, it was to start with set theory and understand and build the concepts and stuff. And it was the right, I lucked out in high school when I took freshman algebra. They got a new guy that came in, and he picked a book that started with, let's learn the field axioms, commutative, associative, all those properties, and the other two teachers that were doing algebra were doing it the old way, and they didn't have math degrees even. And he got the honors class, and it made all the difference. Probably influenced my teaching philosophy too. He was the cross-country coach. Cross-country, these are the guys that say, pain, what is pain? You just keep running. One day in class he said, I had to work really hard to learn math in college, and you're going to work hard too. And so my poor students are the beneficiaries. Yeah, he was right. You're going to learn math, you got to work hard. You're not going to learn it by screwing off. Just like you're not going to be a good athlete or a good musician by goofing off. Scott had a comment.
So I was just going to say, in reference to the question about parents, there are a number of schools, especially middle schools and elementary schools, that sponsor parent math night or parent math events. Some were doing active for a while, called math events, and some are doing some sort of digital courses or events related to that sort of thing. And a number of publishers are now creating support materials for parents may, which are provided online.
That's great. Yeah, the more you get parents involved with the kid in the education, the better the kid is. Closing comments? Okay, so you missed all kinds of fun anime, but that's okay. We'll see you again.